Shu.
Hi, I'm Yulong.
We are engineers from the Mobile Vision team. Mobile Vision team is about providing you with the greatest and latest computer vision algorithm that run privately on your device with low latency and no internet access required. Our API also works both for Android and iOS. Now let's take a look at how it works. So what you have seen is an application that demonstrates how to use the Mobile Vision face, barcode, and text API. First, the application scans barcode from a paper ad, bring the user directly to a product page. Then you use the face API to try virtually the sunglasses on his face. Last, he used the text API to scan credit card real quickly to do the payments. So Mobile Vision API is quite popular. We have 125 million 30-day active users. This number is contributed through more than 15,000 applications. In our community, we see a lot of very interesting use cases. For example, on our face API, we see people use the face API for photo correction type of application, like face blur detection, as well as red eye removal. For barcode API, we see applications that use wedding registry, as well as tracking 2D in space to place 3D object in an AR-like application. For text API, we see applications that do quick payment processing, kind of like what we show in the video, as well as help blind user to see its surrounding. After today's talk, you can join our active community as well to build awesome applications. The Mobile Vision API consists of 4 major components: the Common Utility API and 3 Specialized Detection API. The Common Utility API provides infrastructure and building blocks that help you construct a streaming pipeline. The Face API detects faces. It also understands landmarks like face and eyes, nose and eyes, as well as facial classification, like are you smiling or is your eye closed? For the barcode API, it can detect 1D and 2D barcodes for multiple formats in different orientation at the same time. The text API can detect Latin-based languages. For detected text, it also understands its structure, like paragraphs and line. Before we take a deep dive into the code, I would like to talk about some basic concepts and use cases. So the Mobile Vision API works on both static image as well as a pipeline. The easiest use case is to use on static images. First, you want to create a detector. Then you provide it with an image. It will run detection algorithm, and they will generate detection results. This is what a pipeline looks like. So the camera source that uses the camera API internally, it streams the camera frame to the detector. The detector then runs detection algorithm to generate detection results. After that, it hands over the detection results to a processor. A processor is a first-step post-processing. It's responsible to discard, merge, or deliver the detected item to its associated tracker. A tracker is an event-based object listener. It can notify for a tracked item over time. So the camera source, detector, and processor are provided by the Mobile Vision API. The only portion you need to worry about is the tracker. Tracker is the piece of code you want to write that implement your business logic. Now you understand the basic concepts, like let's take a deep dive with the barcode API. So barcode API sounds boring, but it's surprisingly awesome. If you think about it, barcode is everywhere. It tracks everything. So the airplane ticket you purchased is tracked by barcode, as well as the cookie you ate today is tracked by barcodes. So the barcode API for Android is provided by Google Play Services. You want to declare your dependency for the Gradle and also during the runtime for your manifest file. For Mobile Vision API, the first time when it's run on your device, it requires to download some additional vision models, but only for the first time. Once it's finished downloading, from then on, no internet is required. In this slide, we'll talk about how it's used for static image case. So it's 3 steps. First, you want to instantiate a barcode detector using a builder pattern. The builder will allow you to specify what kind of barcode format you are interested in. In this example, we are specifying QR code and UPCA. So you will ignore any other formats. Next, you will provide with the image, and then you will run through the detection algorithm to provide you a detected barcodes. After you have the barcodes, then you can access its property. Every single barcode has some common property, like raw value, what is the encoded barcode value? Corner points, where is this barcode located on an image? As well as barcode format, is a UPCA, is a QR code. For 2D barcode, it can actually contain structured data. We parse the data for you. So what you want to do is you want to check the value format. In this particular case, it's phone. There's also other value format like contact, address, and others. Once it's parsed, then you can access it through an object that we provide. So that is how you do static image detection. Now let's expand that to a pipeline. Remember we talked about before, there are 4 steps to the pipeline: the camera source, the detector, the processor, and then the tracker. So the first thing you want to do is instantiate a barcode detector, just like we talked about before. Next, you want to instantiate a camera source, and then you want to provide it to the detector. So when the camera starts, you will automatically deliver the camera frame to the detector to run detection. Next, you want to instantiate a tracker. So remember we say tracker is what you want to put your business logic at. It's an event-based listener, and the list are the few methods you can override. So a new item is called when a detected barcode is seen the first time for the pipeline. If you want to add an overlay graphic, like the video we show, into your application, this is where you want to add your graphic. An update is called usually on every single frame when you get an update location for the detected barcode. So in your example for the overlay, this is where you want to update your location. On missing is called when a tracked barcode is missing for the couple frame. This can be due to occlusion or the frame quality is blurred. After several frames, like the barcode just nowhere to be seen, undone is called. Undone is called when the pipeline is releasing all the tracking resources related to this barcode. This is where you want to also clean about your overlay graphics. Next, we want to instantiate a processor. This is where we hook up the detection results to a tracker. The Mobile Vision API provides two flavors of the processor, the focusing processor and the multiprocessor. We will talk about multiprocessor later in the presentation. In this use case, we're talking about a focusing processor. Focusing processor allow you to select one barcode and then focus on that barcode, continue to deliver the notification until that barcode is no longer seen by the pipeline. So this is what the code looks like. You want to override the select focus method. Again, select focus method is only called when there's no item to be focused on. So you get a batch of barcode detection comes in, you select which barcode you want to focus on. That barcode will be continue send notification to the tracker until its undone is called on that barcode. After that, the select focus will get called again, and then you get to select what's the next barcode you want to continue tracking. So that's it. That's how you construct a pipeline. It's very easy, 4-step. You instantiate detector, you instantiate tracker, a processor, and then you hook it all together using the camera source. So the barcode API also works on iOS. The barcode API for Android and iOS share the same common algorithm. So when you use them, you get consistent results for both of your platforms. Our iOS API is provided through CocoaPods. If you only want to use the detector, you can specify the barcode detector pods. If you also want to use the pipeline, then you can also add the MV data output pod. Again, in this slide, we're going to take a look how to use the iOS barcode detector in a static image detection. First, you initiate the barcode detector in a factory pattern. Just like it before, you can specify what kind of barcode format you are interested in. Next, you provide it with the image, and then you will detect barcodes back. Once you get a barcode, you can access its property. All the properties we talked about before are all available here. The raw value, corner points, value format. So this is what the iOS pipeline looks like. It should be seeming familiar. It has 4 steps, just like before. However, to respect iOS convention, we made some changes. Instead of the camera source, we're using the AV capture session to interact with the camera. Instead of the processor, we're using data output, which is a delegate on the AV capture session to hook up the detection result to the tracker. The rest should be fairly familiar. So you want to instantiate a detector. You want to instantiate a tracker where you put your business logic. You're using a data output to hook up your detection result to your tracker. And then you use the AV capture session to stream the camera into the detection. Next, Yulong will talk about Face API.
Thanks. Hello. Now it's turn of the Face API. So Face API makes detect face in static image or video or camera stream really easy. Using Face API, you can build all kinds of fun apps with detecting face in it. In the previous demo, we showed that you can use Face API to build a sunglass try-on app. So users take a picture of themselves or point the camera to themselves. They can see how they will look like if they are wearing a sunglasses. You can, of course, do more using Face API. For example, you can build an avatar app using Face API. User input his photo, and you can use Face API to generate an avatar for the user. One thing to note about Face API is that this is a face detection API. It's not face recognition. So it could detect all faces inside the image or video, but it has no idea about who these faces are. Face API works very well on human faces, no matter the face is with extreme expression or the face is obstructed. Face API could accurately locate the face in the image. And when detecting the face, Face API also reports a list of positions on the face. which we call facial landmarks, including eyes, nose, and mouth, and so on. These facial landmarks helps you better understand the position of the face and the angle of the face. Face API doesn't require you to face the camera directly to make it work. We support multiple angles, and Face API will report you which angle the face is on. Face API also supports some facial activity classification. It could detect if the person's eye is open or not, as you can see from that video. It also could detect if the person is smiling or not. In order to use Face API, the same Gradle dependency as barcode is used. And in the runtime dependency in your Android manifest.xml, you want to specify that you are using Face API so that our API could download the necessary file for you. Once you have the dependency set up, the usage is very easy. The first step is to instantiate a face detector using the builder pattern. You can tell the builder a list of parameters like, for example, you can see I only want to detect face that is larger than 10% of the image size. Or you can tell Face API that I am only interested into the largest face of the image. And if you wanted to do the classification, means is the eye open or not, is the person smiling, you need to enable the classification when building the builder. The same for landmark. If you wanted to detect landmarks, you need to enable it when you're building the builder. And you can tell face detector to run at an accurate mode or fast mode. This is the trade-off between the performance, the accuracy and the speed. Once you have the instance of the Face API, you can apply it on a static image, and you can get all these informations of the face, including the position of the face. And if you enable the classification, you can get the probability of is the eye open or not, is the person smiling. Of course, if you enable landmark detection, you can get a list of landmarks of the face. The same as barcode API, Face API also supports video analysis. So quick refresh of the pipeline. So we have 4 components. We have a camera source, which is responsible for getting frames from camera. And the camera source passes these frames to face detector, which faces will be detected. And the focusing processor is responsible for select the right face and route that face to a tracker. Tracker is where you want to put your business logic in. We will show in the next slide about how to implement a tracker class. So configure the whole pipeline together is very straightforward. You instantiate a tracker, you instantiate a detector, the same as we did for the static image, and you tell the detector that you are using, in this example, you tell the detector that you are using largest face focusing processor, which only routes the largest face to the tracker and omits the rest of the face. Then you build the camera source class, and you start the camera source class, the whole pipeline will start to work. This is what a tracker class, implementation of a tracker class looks like. Most importantly, 2 methods are needed. The first method is onNewItem, which is called every time a new face is detected by the face detector. This is, say, if you wanted to build the same app as we did in the video, that scan the face and put a sunglass on the face, this is where you wanted to create the sunglass overlay on the face. The next method is the onUpdate method. This method is called every time the existing face has some updates. It could be the position of the face changed, or it could be the person smiled, which he or she wasn't. This is where you wanted to update your the sunglass overlay to a proper location. In the previous talk, we only discussed to track one single object, no matter it's a barcode or it's a face. But our API, of course, supports multiple object tracking. The pipeline looks very similar, the same for components. The only difference is highlighted there, is that instead of using a focusing processor, you wanted to use a multiprocessor here. Unlike focusing processor, which only rolls one element to the tracker, multiprocessor will create tracker instance for all the elements that is detected by the face detector. The code looks very similar. The only difference is highlighted. You wanted to create a multiprocessor.factory class, which will create tracker instance for all the faces that are detected by the face detector, and the rest of the pipeline are the same as single face tracking. For Face API, we also have iOS support. It's available through CocoaPods. If you only need to run Face API on static image, face detector is the right CocoaPod you want to use. If you also want video support, you need to include the MV data output CocoaPod. To use the API on iOS is very similar as on Android. The first step is to instantiate a face detector with all the desired configurations. Then you run the detector on a static image, and you can get the property of the face in a very simple way. Again, for iOS API, we support the same video analysis, the same as Android API. The pipeline is the same, except the name of the class changed. Like, for example, it's a camera source that is responsible for providing frames on Android, but on iOS, it's AV capture session. The face detector is responsible for detecting faces, while the focusing data output is basically a focusing processor. And tracker is the same, where you want to put your business logic in. In order to configure the pipeline, the first step is to instantiate face detector and a tracker, and you instantiate a largest face focusing data output, which is basically the same as the largest face focusing processor on Android. Then you use the AV capture session to get frames from a camera, and the whole pipeline will start work. The implementation of tracker is very similar, except the language is different, of course. Two methods. The first method is called when a new face is detected. The second method is called when an existing face has some updates. We again have the same multi-face tracking on iOS, the same as Android. The only difference is that you use a multi-data output instead of focusing data output, so that it will be responsible for creating tracker class for all the faces that is detected. And the code change is very straightforward. It's only one class change. So I'll skip this slide. The next API I'm going to talk about is text API. I personally feel text API is very interesting. You can build a lot of useful apps using text API. For example, if you are building a payment app, you can do what we did in the video demo. So the user can point the camera to their credit card, and you can use text API to extract the necessary information for the user, like the credit card number, the cardholder name, or the expiration date. So the user don't have to type all this information using their tiny keyboard. Or you can build a business card scan app. Take a picture of the business card and extract the email address, the phone number, the name of the person, and save this information to content. This is a short video demo of a text API. As you can see, we support multi-color schemes. It's very robust. And we support multiple languages. Currently, we support all Latin character languages, which are more than 20. And when detecting and recognizing text, text API doesn't only return you the content of the text. It also keeps the structure of the original text. That means in the return value of the text API, there are 3 levels of the returned object. The top level is the text block, which is essentially a paragraph in the original image. And in each text block, there are multiple lines. Each line corresponds to one single line in the original image. And in each line, we report to the multiple words inside the line. The same grid of dependency, if you wanted to use text API on Android, And the runtime dependency, you want to specify that you are using text API, so we can download the necessary file. Although the development of text API is kind of difficult, but the usage is actually very easy. The first step is to instantiate a builder and build the text recognizer. Then you can run it on a static image, and you can get a list of useful information of the text. For example, you can get the language of the text. As we mentioned before that text API supports more than 20 languages. We don't require you to tell text API that which language you are detecting. Text API could automatically detect the language and tell you which language the text is. And you can get the position of the text. Of course, most importantly, the value of the text. You can call the getComponents method on a text block, which is a paragraph, to get the lines in the paragraph. And you can call the same method on a line to get all the words inside the line. Same as our other two API, text API also support video analysis. The pipeline is the same, so I'll just skip this slide to save your time. A quick summary here. We have currently have 3 API. We have a face API, which detects faces, as well as the associated facial landmarks and facial activities. We have barcode API, which decodes both 1D and 2D barcodes. We have text API that recognizes text from an image or video. We support Latin character-based languages, and we keep the structure of the text for you. All these 3 API follow very similar pattern. So if you know how to use one of the API, it's very easy to use the rest of the API. And all the computation of this API happens on your device, so you don't need to worry about the network bandwidth. Now that you know how to use the API, here are some tips about how to make best use of the API. The first tip we have is always run the detector in background threads. This is because the latency of these 3 APIs are higher than 16 milliseconds. So if you put it in a UI thread, your UI will be laggy, and you will have a very bad user experience. Second one is that, if possible, do image pre-processing. For example, if you are running face API on a video and you know that part of the video is blurred, it could be a motion blur, or the light is really dark, so it's difficult to recognize a face, you might want to skip these frames, because by doing that, you can save a lot of battery. And in order to make best use of the mobile vision API, you can also use it together with Cloud Vision API. For those who don't know much about Cloud Vision API, that is another vision-related API developed by Google, runs on Google Cloud, and provides more information for detected items. For example, Cloud Vision Face API provides emotion detection, while Mobile Vision API doesn't. It could tell you if the person is joy or not. But Cloud Vision API has higher latency because it requires you to do a network round trip to cloud. So see, if you want to detect the emotion of a person inside the video, you can combine Mobile Vision API and Cloud Vision API together, use Mobile Vision API as a coarse detector or preprocessor, runs on every single frames you have to detect if there is a face inside the frame or not, or to detect if the face is large enough for Cloud Vision API to do emotion detection or not. Only if you find a large enough face inside the frame, you pass that frame to Cloud Vision API to do the emotion detection. By doing this, you can reduce the latency of your app, and you can get the same result as using Cloud Vision API solely. I'm going to play a video that might give you a better idea about what can we do by combining this local detection and cloud detection together. Thanks. Inside this demo, the on-device detection is responsible for detect if the object of interest is inside the frame or not. If the object of interest is inside the frame, we pass that frame to cloud to do a more detailed detection. That's about Mobile Vision API. And here are some useful links for people who might want to know more about the Mobile Vision API. The first link is our official website, where we put our documentation on. And the 3 code labs we developed for the Android API. These code labs have a step-by-step instruction from how to create a Android project, to how to use the API, to how to build the app. So if you are new to Android development and you wanted to try our API, these three links are definitely very helpful. And we maintain 2 GitHub repositories, one for Android and one for iOS. We put some sample code there. So if you want to know how we use the API, you can check these 2 GitHub repositories. And if you find any bug inside the API, feel free to open an issue in the GitHub repository. In case you have some general questions like how to use the API or why I got this exception, what does it mean? Feel free to ask a question under the Android Vision or Google iOS Vision tag on Stack Overflow. We have developers monitor these tags periodically and answer questions. So Mobile Vision API has powered more than 15,000 apps, and with the cool feature of detecting face, recognize barcode, and text. Now it's waiting for you to think of how to use this feature inside your app. On behalf of Mobile Vision team, Xu and I and Xu's dog would like to thank you all for coming to this presentation.